The lecture question changed today. Redid the lecture question. I didn't really like the old lecture question for this lecture, so I redid it. Made it, I think, better. Better in terms of it'll help you better understand the material. The other one didn't really. It was too easy to cheese it. And when you cheese a question, it just makes the next one that much tougher because you didn't learn what you're supposed to. So I try to make the lecture questions cheese proof. Yeah, I got to get a more recent profile picture, but I had a few minutes and wanted to update things a little bit instead of just the silhouette of a person. Afternoon, JS. You submit this extension, if you're doing an expansion objective, you submit that to the same place you submit the homework. And for that, there's rarely auto graders for the expansions for homeworks, but you're submitting just so me and the TAs have a record of the code that you wrote. You still have to submit the code. You can't just interview with it. So we do still want to review your code. Another day, another 116 lecture. Welcome to society. Yeah, it feels good to be back. Okay. Jesse TV is on? Oh, Jesse TV. Yeah. All right, 150. Let's start this. Prepare for 0.0. What's this week's interview about? It's on the... Can you believe we're on week 6 already? It's lab verification. So it's learning objective. The labs go in cycles every other week. Every other week is a learning objective verification. So you're interviewing about object-oriented programming. Then Thursday's lab is, here are some programs that use object-oriented programming. Talk to me about them. So every other week has that feel for learning objectives. And then on the other weeks, it's the homework stuff. Verifying one homework through an interview and then setting up your testing for the next homework in the Thursday lab. So we're in a rhythm now. Things are the same until we get to the end of all 5 learning objectives. Then things open up a little bit. Things are a little bit different just the last couple of weeks. But we're in a rhythm here. You know what to expect each week. You've already seen every type of assignment that I can throw at you, that I'm going to throw at you. So you know what's up. Okay. So 116 starts, we go. It's not like I streamed before this. You just came to say hi. Toldfish every day. So we're starting the next part of the course. We just finished object-oriented programming. So that's what your interview is in your Thursday lab this week. Talk to me about what you know about object-oriented programming to get that learning objective complete. Now, and with object-oriented programming, the big thing, the word that I said till it lost meaning, was state. Even when we were just working with classes and objects, those classes and objects had state in state variables, and then we applied inheritance and polymorphism and took it all the way to the state design pattern, which changed the behavior of an object based on the type of the object stored in a particular variable using, leveraging polymorphism and inheritance. For your interview, make sure you know the difference between inheritance and polymorphism. They are very related. You can't have polymorphism without inheritance, but you have to be able to explain the difference between the two. That's a big thing that I'm looking for. Tell me what inheritance is, what polymorphism is. If in your mind they all just blend together as object-oriented programming, just make sure you fix that before the interview and know what the difference between these are. We have 2 interviews this week. Some of you will. If you're doing a makeup interview, if you're caught up and passed every interview so far, then it's just one interview. But if you're doing a makeup, if the head TAs contact you for a makeup interview, then yeah, you get 2. Some weeks you'll even have 3. If you keep failing interviews, you might have 3 interviews in a week down the road or more. Until at some point we're just going to say no more makeups, you failed. So don't fall into that if you're relying on these makeup interviews. Anyway, we're starting functional programming. Functional programming is, can you get a makeup interview just because you want to chat with the TAs? If you want to chat with the TAs, just chat with the TAs. You don't have to do a makeup interview for it. So now we're starting functional programming, which is kind of the opposite of object-oriented programming, not exactly, but these are two different ways of approaching problems. So where object-oriented programming, it was all about state, with functional programming, we are completely taking away state. There is no state in our functional programs. If you were applying the functional programming paradigm in a very pure sense, if we have a pure functional program, there's no state at all throughout the program. And the program is a collection and a series, a combination of functions with clear input-output behavior that does not depend on any state. So no matter what, these functions, given the same input, will always have the same output. This isn't true with our objects that have state that can change. The output will depend on both the input and the current state of all the variables contained in that object. So there's a very different way of thinking. I tend to say opposite. It's not exactly opposite, but they are very they are on different ends of a spectrum for sure. So we're going to see how we can write things that don't use state, and with the exception of today's lecture question, we're going to ban the keyword var. You cannot have variables in your code. This is the first thing you learn in 115 is a variable. It's a very fundamental part of programming. And I'm going to take that away and force you to think purely functional for this learning objective. Again, just like when I banned control flow in object-oriented programming, I'm not banning var because variables are inherently bad or anything. I'm just banning var to force you to use functional programming. And specifically, recursion is one thing that if I ban variables, it forces you to write recursively. Otherwise, students will resist me to no end. They will not write recursive methods, even if it's harder to write a non-recursive method. They'll do anything to avoid recursion. And not blaming anyone, I did the same thing. I resisted learning recursion. Once I finally did learn it, I really enjoyed it. But it's a very mind-bending thing. It's a very new concept, and it takes students a long time to really wrap their heads around. I don't think I really understood recursion until I was a grad student. So in this class, I want to get you to the point where you can write recursive functions and start thinking about how they're structured. Even if you don't fully understand them, that's fine, because it is this kind of leap of faith. They do seem magical at first. But with that, let's get into functional programming. And we're going to start by talking about everybody's favorite topic, sorting. And we will talk about sorting throughout your career as a computer scientist. You're going to hear about sorting way more than you've ever wanted to. This is not the last time we're going to talk about sorting. You'll talk about it again in 250, again in 331, and probably in a few other courses as well. We really like talking about sorting. It's a very nice problem, especially for educational purposes, because you know what sorting is. You've known since grade school what the idea of putting things in a certain order is, and then we can leverage that knowledge to teach you about all kinds of other things. Today, we're going to use it to talk about functional programming. In 250, you'll talk about it to talk about runtime analysis. And then in 331, we'll talk about it again to talk about writing proofs and proving that algorithms are correct. So let's talk about it. And I won't really do much big O in this course. We don't really talk about efficiency, but I will mention it very briefly. Actually, in today's slide, I have one slide where I mention it. But let's get into this. So our lecture question today: in a package named functions, write an object named generics with a method named map filter, which takes a type parameter. We'll learn about that at the near the end of today's lecture, and I want to make sure I get to it. Takes a map of ints to t's, so a map where the types are ints and t's, and a function that takes an int and returns a boolean. So here's our two big new things that we want to talk about in today's lecture. The two new concepts I'm introducing today are what we call first order functions. This is a method that takes a function as a parameter. That is something we can do, and it's crazy powerful. And we'll talk about that at length. And also taking a type as a parameter. So this method doesn't work on just one specific type. It works on any type, and that type is set at runtime when this method is called. And then returns a list of t's that are the values of the map for which this function returns true on the keys. So we have a map of ints to t's. If this function returns true on the int for a key, then its value, its corresponding value of type t, is going to go in the returned list and then return a list of all those. Just like the other questions that we had that covered up part of the question. Just like some of the other questions we had that returned lists, the order is not defined here. So in your testing, you do have to address this undefined order. So, and before we just called sort these, but now depending on which type you use for your testing, which can be any type you dream up, you have to sort those in some deterministic order, so you can make sure that the order of these is not going to interfere with your tests. So with that, let's talk about sorting in the context of first order functions, specifically the comparator function. So much lecture questions to catch up on. Yeah, I have always recommended do the lecture questions at the very least before the next lecture. If you're sleeping on them, you have to finish them no matter what. So you got to get the writing part of each learning objective done. It's better to do them on time. If you're feeling the pain now, get caught up and don't fall behind again. Program execution going to be updated. Yeah, over time, we'll periodically do checks and update things. But if you finish all 6 lecture questions, you know that you're going to get the right portion done. It's just a matter of when we update the books. All right. I'll talk to chat later, but I got a lot of content I want to get through. So sorting in Scala, 1 slide, no big deal. We just called dot sorted. We did this earlier in the semester. We did this since the factoring lecture question, we were sorting lists. We just called dot sorted. That returns a new list with all the elements of the input list, but in sorted order. So if I have this list, dot sorted, assign that to a new list, and that list is going to be in sorted order. No big deal. We can sort in Scala. So what's this lecture about? So what this does when we call dot sorted is going to sort in the default order for the type that it's given. So with ints, for example, the default way to sort these is from least to greatest. So the lowest value, -23, all the way up to the highest value in this list, 10. So that's the default order. And we can think of this as having a default comparator that is the less than function. So to compare 2 elements to decide which one goes, how they are ordered relative to each other, we call the less than function. So is 23 less than -8? -23 less than -8? Yes. So -23 comes before -8. So that's how we can determine this order, by using that less than function as our comparator. And of course, we want to talk about comparators. Is what we're leading up to. Here's another way we can sort in Scala. Instead of just saying Scala sort these, we can say Scala sort these by some particular value. We use the sort by method as from the list class for this. We say sort by and then give it some function that's going to translate the values into other values, and then those values are sorted in their default ordering. So here I'm going to give it the math.absolute absolute value technically method in this class, but I'll call it in Scala. I'll call it a function here because we're starting to lead up to functions. We'll give it the absolute value function, and then each one of these numbers, the sort by method is going to apply the absolute value function to all those values, and then whatever the return values are of the absolute value function, that's what these values are going to be sorted on. So now call absolute value on each of these values and sort by those values. So now we get, of course, the absolute value ordering from least to greatest magnitude, not least to greatest value. We did this in 115. So a lot of this is review of 115 concepts. So I'm going pretty fast through these ones. So this is the same as using key, setting the key in Python and sorting by a specific key. And next, the third way, I do want to talk about first order functions right here. So we just passed a function into a method. We can do this. It's very powerful, and this is the big thing that we want to talk about today and a little bit more in the next few lectures. So we can do this. We're calling a method and giving it a function as one of its arguments. So just like we can pass ints and lists and objects of our own created types to methods, we can also do this with functions and other methods we'll see in a little bit too. So we can give a function to a method. Seems pretty crazy at first, but this is something we absolutely can do. So this still is a little bit limiting. So there's a third way that we can sort using Scala built-in methods. The limitation that we have so far is that we always have to sort on the default ordering. We can choose what to sort on by given sort by some function, and then sorting by the default by the output of that function. But whatever the output is, we're still using the default ordering. So what if we want to deviate from this and we want to sort by some other way? For example, decreasing order. Something we couldn't quite easily do. If we're given an absolute value, we would have to write another method that takes the absolute value and then the negation of that to get in decreasing order. We could do it, but it starts to get messy. But we're just going to use this third option, sort with, which is going to take a function in the JavaScript style that you saw in 1.15. Sort with is going to take a function that takes two values of the type to be sorted and returns a Boolean. And this is where we're going to see a little bit new stuff, if nothing else, new syntax right now, is we just created a brand new function, and now we are literally talking functions here, not methods, because this function is not attached to an object. We have a function that takes two ints, and we want to use this to sort a list of ints, and it's going to return a Boolean, which is the greater than. We're effectively sorting on the greater than operator, so we're going to sort in decreasing order instead of increasing order. So the structure of this is like that JavaScript function. If this returns true, the first parameter comes before the second one. So if my arguments are a equals 10 and b equals 7, that's going to return true, which means 10 or a comes before 7 or b. So this returns true. That means the first argument goes before the second argument. Otherwise, the second argument comes after the first argument. So ties are broken in ties aren't broken. So and it's just false otherwise. I almost misspoke there. So and then false otherwise. So true if A comes before B, false otherwise. So if you want to figure out if B has to come before A, you would reverse the input values. You would call, like if I had 10 and 7, for A and B, I want to call this, it's going to return true. 10 comes before 7, cool. If I wanted to check it the other way, I would call this again with 7 and 10. That's going to return false. So I don't really learn any information with that, but whenever I reverse the what's A and what's B and get more information. And this can be used to compute equality as well. So if I have 10 and 10 are my values, I would call it 10 and 10. That's going to return false. So I know that A doesn't come strictly before B. There's no set ordering there. But then I reverse the ordering and I say 10 and 10. I mean, it's just the same thing. It's going to return false again. So then I know that the other 10 doesn't come before this one. And of course, I wouldn't know that they're both 10 beforehand. But if it returns false, no matter the ordering, so A is strictly greater than B, and A is not strictly greater than B, and B is not strictly greater than A, I know I have equality on my hands according to this specific comparator. So if the returns false, regardless of the order of the inputs, then I have equality, and then there's order in the final sorted order doesn't matter. It's a tie. It can be broken arbitrarily. You can write these any way you want. If you want to do it small, if you want a more complex code here. I'm just using greater than as a proof of concept, so I'm not throwing too much code out there when I'm just introducing first order functions. But yeah, you could do a greater than b or b less than a. Is that a strict inequality? Isn't that just the same thing as a greater than b? Those are both the same. It's doing the same thing. What does the arrow mean? Yeah, I got to keep moving on. Good call. So this is the new part that we want to talk about. This is a first order function. This is a first order function, which is a function that we're using as an argument to a function, or the return value of a function, or as a parameter when we're defining our own methods. This is this idea that a function in Scala is just another value. It's technically an object. It's just another value in Scala, and we can pass it around just like any other value. We can have variables that store functions. We can have, I already said the other ones, functions as parameters, functions as return types, functions as the type of that's stored in a list. We can have a list of functions. We can do anything with functions that we could do with, for example, an int. It can be used just the same way that we use the int class, the int type. We can have types, function types of the same way. So this is the definition of a function. I guess I should have excluded these outer parens because that's the argument list of the sort with function. But this is how we define a function. We're going to give it a parameter list, just like we would when we define methods. We're going to use the same syntax, parentheses, and then a comma-separated list of variables with types attached to them. So this is a function that takes two ints named a and b, just like if we wrote a method that did the same thing. And then we have this big arrow. I've warned you earlier in the semester, the developers of Scala really like their arrows, and I'm not complaining. I think it's a cool way of doing the syntax. It communicates quite a bit of information there. And then this arrow function is saying, okay, I have a parameter list, and I want this to be a function, and everything to the right of the arrow is going to be the body of that function. So the body of the function is just a greater than b. For the sort with method, the function has to return a Boolean. A greater than b is a Boolean expression. It's going to return result either true or false, and that's going to be the return value of this function. Yeah, big arrow. With the double equal, where like if you're creating a map and mapping keys to values, you have the little arrow with just a dash greater than. Yeah, there are a lot of different types of arrows. Yeah, P, this is an anonymous function because it doesn't have any name. I never named this function. I can't call this something. I don't have it stored in a variable with a name or anything. It's an anonymous function. Oops, I did get ahead of my slide. I said all this stuff, but no, I didn't. And we can also store these functions in variables. So I mentioned we can do that, but how? So with once we have this function that we created, so this, I'm just rewriting this to be able to store this function in a variable and then give it to the sort with method. I'm doing the same thing to create my function, which is creating a new object, which is a function, which goes on the heap and then returns a reference to this function, just an object like anything else in Scala, and then assign it to a variable named comparator, or a value here, of type comparator. And then the type of a function we always have to specify the type of our variables. Our type for our function is going to be the combination of the types of the parameters and the return type. And we use the same big arrow syntax that we did when we're creating the function itself. So this function takes an int, it takes two ints and returns a boolean. So its type is int to boolean using this syntax. Parameter list goes in parentheses. All the parameter types, no variable names here. The variable names are not part of the actual type of the function, but all the types of the parameters. Big arrow, and then the type of the return type of the function. So we have this creating a function using this syntax, a parameter list, give our variables names, just like we're declaring a method. Big arrow, method would just be an equal sign here. Here we're using big arrow for function. And then the definition of the function, the body of the function. We could also do this in another way. If we want more room, we can use braces just like we do with methods. The only difference here, we have the big arrow notation instead of the equal. Other than that, this is a method here. Mostly the same syntax as with methods. When we say def some method name and then parameter list equals body, we can still do that with braces and define a whole code block. So if we want more than one line for our functions, we can still do that. We can use our braces and have as many lines as we need to define the bodies of these functions. Typically our functions are short, mostly one-liners. Once they get longer than that, it's probably better to define a method and then use the method instead of a function, typically, as a matter of style. So we can do that. And the type, going back to without the braces, the types of all the inputs in parentheses, big arrow, and then the type of the boolean. So if we're declaring like an int, the type of an int is just int. The type of a function is a combination of all of its input types and its output type, its parameter types and its return type. Function is the new state. So this is a first order function, and really most of the next 2 weeks is exploring the implications of this idea that we can have variables and values floating around our programs that are functions. That's what we're going to explore. So hopefully this part makes sense. We can digest this a little bit here. So functions are dynamic even if they have the val keyword. So this comparator can only store a reference to this function because of the val, but I can pass this around and I can call this function as many times as I want. But the function that's stored at this comparator is not going to change because I used val. If I used var here, then I could say later on in the code, comparator equals a b to a less than b, or absolute value of a less than the absolute value of b, etc. The arrow doesn't quite mean braces. We'd still have to have our braces if we have the arrow. The arrow is the syntax that's telling Scala, hey, I'm making a function here. Make sure you treat this as a function. If we just had an equal sign, that's an assignment. So like when we create methods, we're saying, I want a method named this, and it's going to be assigned this code. That's going to be what the method definition is. But here we need some different syntax because we can assign functions to variables. So if we use an equal sign here, Scala's parser is going to get confused. Which one is the assignment and which one is saying, give me a function? So we needed a new symbol to say, this is the parameter list of a function, and I'm creating a new function here with this big arrow syntax. 191's the best. we're getting into some 191 territory here with the functional programming. Can we ban 191, please? No. Oh, we shouldn't be talking about who even brought up 191. Do we need a new project when var will be banned like we did with when conditionals were banned? Yes. Yeah, you will. Because if you have any vars anywhere in the code that you submit, it's not going to compile. Yes, you can use val. So the idea with once var is banned, and I'll talk about that more Wednesday once it's actually banned, is you can't have a variable, declare some variable, and then keep changing its value, which is something we do very, very often. It's obviously a very useful thing in programming to use variables. You can use values as much as you want, but as soon as you declare a variable, its value cannot change. Or once you declare a value, it cannot change. So a function, just to reiterate again, hopefully this is sinking in because we're going to start looking at implications and applications of this. So this creates a function, puts it on the heap, returns a reference to it. We store that reference in a variable. That variable's type is its parameter types and its return type. And we can use this anywhere we can, a regular variable. We can have a method that takes a function of int to Boolean, and we can call that function later on in our code. Comparator does store a reference. Yep. So this puts a function, this function definition on the heap, returns a reference to that function, and that reference is stored to comparator. So when we say that sorts with comparator, this doesn't create a copy of the value. It doesn't pass the value of comparator. Well, technically it does. Technically it does pass the value stored in comparator, but that value is a reference. So we're given sort with a reference to the function on the heap. Functions can't change. They're what we call immutable, which is a topic for next week. So pass by reference, we're not going to get those usual side effects where you could change its state. We don't have any state in functional programming. We're getting rid of state completely for 2 weeks. So we don't have to worry about those pass by reference things changing state. Yeah, good question. Human Hamza Malik 96. So I saw it in chat, this sounds like calculator, I believe was said. Maybe I imagine that. Sounds like calculator. So there was a hint in the calculator handout. So if you're still working on that, I strongly recommend, now that you know what first order functions are, is to use them in the calculator assignment. So you have this situation where each time you hit an operator, like if I hit 2 plus times divide, that operator is constantly changing each time I hit a new operator button. And a lot of students are tempted to have a separate state for each operator. You have 4 states for each operator, and then that just multiplies all your states by 4. Now you have 4 states. Am I working on the left-hand side? And in the addition state, am I working on the right-hand side? Is this after the equal sign was pressed or after an operator was pressed? And times 4 for each one of the 4 operations. So you can do that with states, but you can significantly reduce the complexity of your code and your design if you have a state variable in your calculator class that stores the current operator. And then each time when those operators are hit, as long as you're in a state where the operator buttons matter, just have it override this value of type double, double to double with whatever operation you want to store in that at that time for the calculator. And then when it's time to call an operation, you take this operation variable, and I haven't showed an example of it yet, we will get there, is call this with the left-hand side and right-hand side that you've currently built. And you can do that with operation, this dot operation, and then call it just like a method, give it parentheses, and give it the 2 input values, the arguments, and it'll return whatever operation is in that variable at that time. And we can also use methods as functions. I have this example in the repo. If we have a method, so this is defined as a method using the def keyword as part of an animal class. This compare animals takes two animals and returns a Boolean and sorts them by their names with case insensitive, not case sensitive. And then I have a list of animals, which are using some polymorphism, cats and dogs. And then sort with, give it that method directly, assuming we're still in the animal class here, or else I'd have to do animal dot or some way to access this thing. And give it that method, and it'll sort just the same as if we gave it a function. So we can use methods as functions as well. And this method, does what it's supposed to do with this code. So just kind of a note that we can use methods as well. There's no stopping the way you can sort. So that's how we sort, just using the Scala methods, the built-in methods, and defining our own custom comparators. But how does that work? Now I want to, and most of that was, I guess all of that was review, except the quick animal example that came and went really fast. Other than that, it was review of 115. We do have you using first order functions in 115, but we don't really make a big deal of it. We don't really even talk to you about what just happened. You just use first order functions, and then we kind of hide the details under the rug. So now in 116, we want to talk about how all that works. So what happens on the other end? Once this sorting method gets a comparator and a list it needs to sort, what does it do with that? So let's revisit selection sort. Why do functions and methods have different syntax? That's a good question. I mean, I don't have a good answer right off the top of my head. There are good reasons for it, but I couldn't give you a quick off-the-cuff answer right now. They're just different things. Scala was built like that. Yeah, I don't have a good answer for you right off the bat. So let's revisit selection sort, and then I'll show you an implementation of selection sort that uses first order functions. So for this, we want to iterate over the indices of a list, and for each indice, figure out which value goes there. And I'll go fast through this selection sort. I don't want to spend too much time reviewing this. But for each index, you figure out which value goes there, and then swap values to get the correct value in that location. So an example of sorting this list, we're going to start with looking at the first index of the list, and then check each element as we go through the list. And we're going to have some comparator, some way of comparing these. For this example, I'm going to use the less than operator to do the default sorting order. And then we're going to check, is this value less than this one? No. Is this one less than this one? Yes. Okay, so this is the smallest value. Is this one, actually, well, it would be the other way. Is this one less than this one? No. Is this less than this? No. Is this less than this? No. Is this less than this? No. We got to the end of the list, and we found this to be the minimum value. So we're going to swap this. We know this goes at index 0 in the final sorted order. So we're going to swap these two values. Swap negative 23 and 5, and then move to the next index and ask ourselves which value goes here. When we check this one, we're going to say, does this come before this? Yes. So that's our new min value found. Is this less than this? No. This less than this? No. Less than this? No. End of the list. This is the smallest value we found. Swap these, and then move on to the next index. We do this for each index of the list. Just find the smallest value of the remaining elements, and once we get an element in position, after we know that that's the value that goes there in the final sorted order, we never revisit it again. We move on just to the remaining parts of the list. And sometimes we don't do any swapping. Compare, does 10 come before 7? No, so 7 just stays there. My code actually does swap it with itself, which just has no effect. And then we get to the final sorted order with selection sort. Oh, are we only at 81? So, how does that work? So that's the kind of the verbal explanation. Here's our code to do that. The big part here, we're going to take a comparator. So we could use this function, this method to sort lists in any order using any comparator. So we have to be generic enough to be able to allow for that. So all of our code can't take the comparator into account. We can never say less than in our code. We have to call a comparator that follows the criteria of that less than method. Specifically, a value of function that takes in 2 ints, returns a boolean, returns true if the first input comes before the second one, and false otherwise. So we don't know anything about this comparator when we write our selection sort. Just like when the developers of Scala wrote sort with, they have no idea what function you're going to give it. They don't even know what types they're going to be sorting. Those built-in sorting methods in any language have to work no matter what the types are and no matter what the comparator is to give us the maximum flexibility so we can sort our own types in our own ways. So we're going to do the same thing here. We're going to take a comparator and then just refer to this comparator whenever we need to know how to sort things. And I'll quickly go through the code here. We're going to iterate over the indices of this list. Whenever we, for each indice, we're going to track the min value found and where it came from. So we have to track what its value is and where it came from. And then iterate through all of the indices from that index on and use our comparator. We're going to get the value that we're looking at. We're going to call the comparator. Is the value that we're looking at currently considering, does it come strictly before the min value that we've already found, with ties going to the min value that we've already found? So if the same element appears multiple times, we're going to choose the one that we saw first, just the way that we're coding this. Does the value we're looking at come before the smallest value that we've already found? If so, update the smallest value that we found. And then after looking at all of the rest of the array, whatever that smallest value we found, swap it with the value at the index that we're looking at. And then return the list after it's sorted. So that's the code. That's the Scala implementation of what we talked about on the last side. Yeah, var isn't banned yet, flip-flops. There's going to be a lot of var here. If I could write this without var, but you might not be able to read it. I almost did this morning, actually. I almost rewrote this just for fun and put it in the repo. Maybe I'll still do that. No, this is my code. This isn't Scala developer code. This is a pretty horrible implementation of selection sort, actually. If this was in the standard library, it'd be awful. Just for fun. Yeah. Hey, I like what I do. What can I say? So whenever we need to compare two values, this is where we're going to use our first order functions. We have this comparator that takes 2 ints and returns a boolean. And whenever we have a question about the data, we take that comparator, call it by the variable name, but call it just like it were a method. We're going to give it an argument list, and that's going to call this function, whatever it is, whatever it happens to do. The only thing I know is that it takes 2 ints and returns a boolean, and I'm hoping whoever gave this to me followed the criteria that it returns true if the first int comes before the second one, false otherwise. I'm going to call that, and whatever it gives me, I'm going to make decisions based on that. So the only thing, a little off. So the only thing I ever do with that comparator is call it with 2 values. I'm only ever comparing 2 values at a time when I'm sorting. So when we use this as the interface, and this is how languages can sort anything, they just use this comparator idea as is kind of a black box where we don't know what it does internally. It just works by magic and it works great. So as long as we take 2 values and can compare 2 values, we can sort an entire list of elements just using that comparator 2 values at a time. And with that, now whenever we want to sort something, we just give the built-in sort methods a comparator that compares 2 values at a time. And then the sort method is going to figure out, okay, which 2 values do I have to compare at which times? My code does that, iterating through the indices and comparing values like this. Is how we get the functionality we want. And then if we want to use this, if I want to do this, use the selection sort, give it a list of numbers, give it a comparator. I'm going to give it the greater than function here. And though I could sort however I want with any function that compares two ints and returns a Boolean, I'm going to use the greater than to sort these in decreasing order. In my code, it's going to work. It's going to sort these in decreasing order. Another issue here, how do we do this with our custom types? So we saw this example before. Our Scala's built-in sort with method can handle any type. But the example, and I said we need to be able to handle any types. But the example I gave you was specific to ints. So this is an issue that we need to correct. What if I want to use this example that I used with sort with? What if I want to do this with the selection sort implementation that I just showed you? So that selection sort only handled ints. That's no good. How we're going to resolve this is with a type parameter. We're going to specify the type when the method is called. Just like we give other arguments as values, and we have value parameters, we're also going to have type parameters which specify specific types. So we're going to rewrite our method just a little bit. We're going to, instead of just being a hard-coded int selection sort, we're going to have a selection sort take a type parameter as part of its type parameter list, which comes right before the regular parameter list, but uses brackets instead of parentheses. So we can have a second parameter list which takes type parameters, and this can be any type that somebody gives us at runtime. Now we can't access anything specific about this type because we have no idea what this type is. It could be any type that the caller specifies, but we can use this type throughout our method. So if somebody says, I want to sort some type, well, as long as you give me a list of that type and a comparator that compares that type, I'll return you a list of that type in sorted order. I don't even care what that type is as long as you supply the list of that type and a function that works with that type. So I never have to use any of the functionality of that type as long as the caller provides the right parameters that match that type. I'm only calling their parameters, their inputs. When I call the comparator, I'm just calling it on two values from the list that they provided. I don't care about anything else, so I can have a completely generic sorting method that can sort any type with any comparator without having to know any of the details at the time when I write up this code. So now when the developers of languages, they write these standard libraries and these sorting methods, they only focus on the algorithm, the actual sorting algorithm itself, and then they write it very generically to take a comparator and a type and can sort anything, any type, any comparator that it's given. Type was given. Yeah, type. And when we have type parameters, so type could be anything. That's just a variable name. And our names for these types, we usually just reduce them to a single character. I'll just use T here. Other ones common for A and B are common. For the map class, so we have used type parameters before. Like we create a list of some type. We're giving a type parameter to the list and saying, give me a list with this as the type parameter. So we have used these before on the other end. In the map, a map takes two type parameters, and those type parameters are usually K and V for key and value. But we tend to, whoever decided to do this first got to call the shots, I guess. But we use single variable, single character names for generic types from our type parameters. If I just want to sort one type, yeah, I mean, we already did that. But this can be used to sort, if you only use this to sort one type, whatever, it's ready. It's got more power ready and waiting for you. But if you only want to sort one type, yeah, whatever. Just only sort one type. And now when we call the method, we can give it the type parameter when we call it. Or we can just let Scala infer the type parameter. We usually don't specify the type parameter explicitly. If I call this selection sort method, give it a list of animals and a comparator of a function that takes two animals and returns a Boolean, Scala's going to figure out what I'm doing. Scala's going to say, I think T is animal, because that's what you've provided. You gave me a list of animals. The type parameter of the list is animals. The input types of the function you gave me are animals. I get what's going on here. T's an animal. So Scala's got our back on that, but we can specify the type parameter if we want to be very explicit with what we're doing. So a note on that selection sort algorithm. It works, it's fine, but it's horribly slow. The algorithm is an n-squared algorithm. My implementation is even worse than that. It's n-cubed, just with how sloppy I was coding it. I was going for readability, not efficiency on that one. Because of a lot of inefficiencies I used with the list class, which in 2 weeks when we get to data structures and algorithms, we'll actually crack open linked lists and talk about how they're made and what they do. When we get to that code, I'll explain to you why this was n-cubed. If you want the really short version, when I call the apply method, apply is a very slow method. It's a linear runtime method because it has to navigate, traverse the entire linked list and jump all over memory just to find the value that it's looking for. Just to go, if you say, give me the last element of this list, that's a crazy slow operation because you have to traverse the entire list just to get to that last element. So that's where we get the blow up of n cubed. I also have a lot of space inefficiencies. I'm creating a whole bunch of new lists, and it's very slow. So don't think that I showed you beautiful, efficient code there. I was just showing you that as an example. And we will talk about that. I will leverage that horribleness to talk about linked lists in 2 weeks. And the n squared, as for this one, we will revisit merge sort on Wednesday and get this n squared down to our n log n. And in 115, we showed you merge sort, if they even still show you merge sort. But if they did, it was very quick. It was half a lecture and said, here's merge sort, ain't that cool? See you later. In 116, we want to revisit that and really look at how merge sort works. And we can't really do it in 115 because you don't know about recursion yet. But we're going to use that to introduce recursion and talk about how merge sort actually works without just saying it's magic. We're going to take a look at that recursion and how that code just kind of magically works. And back to the lecture question. That was a lot. We had there were two main concepts today. This wasn't, there's more than 6 things I need to talk about these 2 weeks. So I have to get 2 in one lecture here. But we talked about type parameters, and we talked about taking a function as the input of a method. So those are 2 big takeaways for this lecture. And those are 2 big things that you need for the lecture question. So that's the end of lecture officially. Hey, only 2 minutes over. That's fine. And I spent at least 2 minutes just talking about chat. Demo time. What am I supposed to be demoing today? Or do you just want me to demo what we just saw? Did we talk about something I'm demoing? Yeah, I changed the lecture question this morning. So if you're doing the lecture questions before the grader is live, the lecture question might change. It's not until I post the grader that the lecture question is finalized. So once the grader is posted, go to the slides, refresh, and make sure the lecture question didn't change on you. This one definitely did. Why do functions and methods have different syntax? Yeah, I still don't have a good answer off the cuff. Why do functions and methods have different syntax? I'm sure there's a great reason. I'm just blanking on a quick answer for you. They're different things is the best I can do for you right now. Why do maps and lists have different syntax? It's not a satisfying answer though. That different things have different syntax. But yeah, I can do a demo. I can let me just demo some of the code I showed from lecture. Is this sized right? Okay. Week 6 already. Crikey. Homework speedrun. This lecture question seems kind of hard. So this lecture, I do think about the difficulty of lecture questions quite a bit. This one, it's on the easier side of difficulty, but since it's two brand new concepts, it is a bit tougher. But once you know those concepts, the lecture question isn't too hard. As opposed to what I'd call a difficult lecture question, factoring, for example. That's one where you can understand the concept of testing and sorting lists and everything and still have quite a bit of work to do to actually solve the lecture question. That was a difficult lecture question. But this one, once you get the concepts down, the concepts themselves are difficult, which makes this one difficult. But once you understand them, since the concepts are difficult, I made the question itself a lot easier. What am I demoing? There's a lot of demand for a demo. Philip Stanton, it's not the time to talk about missing interviews and stuff. Make a private post on Piazza, like Lana said. Application. For the application objective, do it small. No, I mean, interviews just ended Friday, and I didn't look at them this weekend. But I'll talk to the TAs and figure out how we're going to handle that. I might just do it for this first one, just to see kind of how the course is going, how the students are handling everything. But we'll get that to you. Use type parameters on functions, or can there only be used on methods? I don't think I've ever tried, to be honest. So if I want to create a function of type int to int, I'll stick with the name from lecture, and just adds 1 to A. Can I have a type parameter right here? I would have guessed no, but it's good to know. What I could have, but what I can do, if I needed, I'm trying to think of a situation where I'd need that. But what I can do is create it inside a function or a class. You can have type parameters for a class. Where's my class? I'm in an object. But you can, anywhere where you have a type parameter already, you can use that type parameter. You can use that type parameter in your function. But I don't think there's something you can do to have a function actually take a type parameter. Too bad TAs never answer questions. I mean, they do. Like, to be honest, I think the class is a bit spoiled. When you get to other classes, the TAs are not as on the ball on Piazza as they are in this semester. That said, we have a huge volume. It might not show up, it might not look like it to each student because so many of the posts are private, but you can look at the index on the posts, look at the latest public question, and look at the index number of it. You can know how many private posts we're getting. And they're usually good about it. Once the questions are silly, I mean, I might as well just read your question. I need to make up last week's interview because I missed it. I haven't received an email for a makeup. I also got a 0.0 for explaining on Learning Objective 1. I know I need to pass the course. I'm just confused on how to make up explain for the Learning Objective 1. Uh, I think that was said. So this is something that they probably wouldn't answer right away because I feel like that's been said so many times already. You'll be contacted for any makeup interviews. We should be getting them out about mid-week this week to be able to get your makeup interviews for that. I know it's tough, but you got to be patient on some of these things. Just we just finished processing all those interviews. There's a lot that we have to do behind the scenes when we have um, like 150 or so interviewed. We had to take all that information, and there's just a lot of logistics that go into it. So to get to the point where you need makeup interviews, and to be honest, we don't want to do that too fast, because if you have an interview and we notice you failed the interview and then give you a makeup interview right away, well, you probably still don't know that stuff. You need some time to study. So the makeup interview shouldn't be right away. I've actually been talking to my TAs about that, and saying we should have at least a 2-week cool down. After you interview, you have to wait at least 2 weeks before you can interview. So we might even hold off on those for a bit longer, because, I mean, if you used up an interview opportunity, that means you missed something. You need time to study it. There's a lot of things that are better for Piazza. Yeah, thank you. Do a small and P. Impossible shift. There were a few shifts that weren't allowed. The incorrect solution allows those impossible shifts. Clear not complete for the homework. Do it small. Did you rate tests that hit the clear button? So for that incorrect one, clear doesn't clear everything. It's just not complete. So you have to have a test that's hitting clear and then doing a whole bunch of other stuff. Doing stuff, hitting clear, and then doing other stuff. Then you'll find its error. Yeah, thank you, PJB. I've taken classes, and I see some of my colleagues' classes. Like, you can be waiting days for any Piazza post. My TAs are all over Piazza all the time. They're constantly on there. And then it's one of those things where it doesn't matter how much you do, students are always going to want more. We have very fast turnaround on Piazza, and now students are expecting that instant gratification. I post a Piazza question, I need it answered right now. Right now. Where are you? Why aren't you on standby all the time? So I don't think there's anything we can do to satisfy everybody on Piazza. People want instant answers. It just doesn't. I mean, we're not always on Piazza. We do other things. The TAs do other things than watch your Piazza posts all the time. Especially when somebody's a serial poster. If you've posted 50 times already, you're taking up a lot of their time. I'd say, I don't know. I don't want to go down that road. And it'd help, honestly, what would help us all, which would help the whole class, is if you can ask your questions in public posts instead of just asking, what's wrong with my code? If you can word it in a way that gets to the root concept that you're misunderstanding and then make a public post, because then everybody can see it. Problem with the private post is we answer the same question like 20 times, and we just get sick of answering the same thing. So if you're the 20th person to ask the same question, sometimes myself and the TAs, we just get sick of, well, mostly the TAs for Piazza, just get sick of answering that same thing over and over and over again. Especially if it was already answered in public places. I don't see, there's a lot of demand for a demo, but no specific what to demo. We only got 7 minutes left here. Yeah, you don't have to apologize, Philip Stanton. In a lot of when I do, like, I'll give students sass in chat fairly often, more often than I should. A lot of that is based on what I just said. When I get the same question 1,000 times, you didn't do anything wrong. It's just that I'm sick of always hearing the same things, and I try to answer them publicly. But when the word just doesn't get out to everybody, when we have 46 viewers right now, the things I say right now aren't going to reach the whole class. So it's just a general frustration on my part. Should I consider the number on the display as degree? Wait, what? The radian button. Anything that's not specified in that expansion objective is up to you to define how it behaves. I forget exactly what I wrote up. But that'd be up to you if it's not defined in the write-up. Since that's not auto-graded, you're demoing it. So you can just explain in your demo. I did it this way because it wasn't clear in the doc. Yeah, you have to do it small. Do it. We do TA hiring at the end of each spring semester. We do hiring for 115 and 116. And the way it went this semester, all new TAs started off in 115. You might have to go there for a semester. Just because we hire in the spring for the fall, in the fall we need so many more 115 TAs because we have a class size, it's like 700 now versus about 200 in 116. But then in the spring, 116 is the big class. So, but yeah, do it. When I make those announcements and stuff, apply. And Dr. Alphonse will send it out to the undergrad listserv. None of the TAs are grad students. I have my opinions. Grad students tend to be kind of hit or miss for TAs. If we hire undergrads, we can handpick them. Grad TAs are the primary qualification they're hired on is can they do research as PhD students. They don't always make good TAs. So I stopped using them a long time ago. I was sick of getting... Some semesters I get great TAs, some semesters I get terrible TAs. With undergrads, I always get good TAs. I mean, with rare exceptions, but... FP approach to calculator. Where's my mouse? Oh, here I am. So, like, for calculator, you would want... Like, if this was my calculator class, I would want some var... So this is what I showed in lecture. I would want some operator that takes a double. So on purpose, every operator follows the same structure. Unless you're doing the expansion objectives, then there are unary operators that take one double and return a double. But on purpose, every function takes two doubles and returns a double. So if I said I want some operator some variable that's going to store my operator, and then maybe I have inside my state, I have some add press method or whatever I called it, I forget. I would say operator equals double A plus B. And then when I have some compute method, whatever method I'm calling when that equal button is pressed, assuming I'm in the right state that something should compute, then I'll do, you'll have two variables, LHS. If this is how you're setting it up. There are a lot of options. There are a lot of different ways you can design your thing. But if you have these, and then compute is going to go operator of. So now the compute doesn't care what is stored in operator. You just care that when the operator buttons were pressed, this variable is overridden with the proper thing. So now we're changing the behavior based on the function that's stored in this variable and not only on the state that's changing. So it's a way we can sneak a little functional programming in there to make our jobs a little bit easier instead of going pure states. And we can do this without control flow. We don't care when the add was pressed and we're in a state where that means something. We don't care what is stored in operator when that happens. We're just going to overwrite whatever's stored there with whatever happens. So we don't have to conditionally do anything. We just store a different value, a different function in this variable. Yeah, online makes things harder, and that's why we have the TAs on Piazza so much, especially online. I mean, that's something I always like. I always push my TAs and try to get them login hours on Piazza, but especially online only, it's a must.